Welcome everyone to the September session for Ask Tom Hours Autonomous Health Framework. Fresh from Open World, I have with me Klaus Thielen, who's the architect or one of the architects on our Cluster Health Advisor development team, joining me this month to ask questions about a very interesting and useful graphical user interface called the Cluster Health Advisor GUI. Klaus, do you want to just introduce yourself and give us a little bit of background?
Yeah, my name is Klaus Thielen. I've been working with Oracle in Germany since 1989. I started there as a regular sales consultant, and very soon I specialized myself to be a performance tuning specialist there. I did a lot of customer tuning, a lot of proof of concept during that time. Later, I got an interesting job. So my job was to traveling back and forward between Germany and the Oracle headquarters in Redwood Shores. And after I think 10 years ago, I joined an interesting team which was starting to build something new using machine learning algorithm to scale performance and HR related stuff. So, and since that time, I was a virtual member of that team, and I worked together with some other performance engineers and architects. Just to say some few names. This is Michael Zoll, Yasser Suleiman, Wardroom Yoshi, and of course myself.
Okay, thank you. So just a bit of housekeeping here. This is a recorded session. It will be up on the Ask Tom Office Hours YouTube channel sometime next week. Everyone except Klaus and I are muted. Therefore, please ask your questions in the chat. Please do not specify any specific SRs. We're not a substitute for SRs. You can please ask your questions in a way that it can benefit everyone. And so we can have a very useful session for everybody. So to kick things off, since this is a question and answer session versus really a presentation, I'm going to open up initially for questions from the audience as to whether or not anybody online here currently has any questions. We did not get any in advance, but I do have a bunch of questions that will warm everybody up if nobody has some questions right off the bat. And it doesn't appear that there are. So in that case, we'll start off with questions off the bat. And my first question is, what is Oracle's goal in developing the Cluster Health Advisor GUI, actually?
Yeah, Mark, when you start to develop this stuff, all our test cases were quite simple, quite easy. So it was easy to scan and look at the log files. But after a while, our test cases got complicated and more complex. So it was not that easy to scan the log files anymore. So we thought about a different way to verify the outcome of our machine learning algorithm. And therefore, we developed CHA GUI. And this, I think it was very helpful and is still very helpful in our process of enhancing the Cluster Health Advisor.
I see. Okay, so you're saying it was initially developed for internal use then?
Yes, it was.
Okay, so if that's the case, why is it now available for customers to make use of?
You know, sometimes when you get a result from a machine learning algorithm, you would like to know what is the reason behind. Is there you would like to be confident the decision you get suggested from the system is the right one. So you would like to see what was the base for it. And since we have this graphical user interface, since we are using it quite heavily in our development process, I think it was nature to share it with the customers as well.
I see. So since it's now available, what does this tool actually look like?
Mark, I would suggest you bring it up, and then we could
Yeah,
look a little bit
yeah.
about it. So, see, this is the tool. This is a session we're recorded in our lab. When you look at the upper right corner, you see, okay, in upper right corner, you see a brownish box. Then when you go to the left, you see the green bar. This is our time line. You see some red bars within it. This red bars shows some problems, some decisions that the CHA GUI, the CHA made, and the CHA GUI is showing. When you go to the left, you see our cloud, and below you see a machine name. When you collapse that, you will see there are hosts. In our case, this is a 2-node cluster, so we see 2 nodes. You will see databases. We have 2 databases running on that cluster. And also what you see is the instances.
Okay.
So when you go back to the brownish corner on the upper right side, this is about 1 hour of time. When you go down, you see a timeline for the cluster, which is exactly the same time frame as the brownish box on top.
Mm-hmm.
And you see there are hosts and databases.
I see. Okay.
The red color shows there's some problems, and you see this somehow collapse. You see the databases and the hosts are combined to the cluster, and you see the cluster is showing all the times where problems was simulated, and the host had a little bit less, and the database had different times where we have problems.
Mm-hmm. Okay, so I see that the hosts and databases are separated. Are these results correlated across them?
This is a very good question. You would assume it is like that, and somehow it is. But in general, we have 2 different models. One model for the hosts, and another model for the databases. And as part of the database model, we have also some signals which we get from the host. So somehow correlation, but not in the way this tree is tried to show us.
So this correlation is more time-based versus analysis-based.
Absolutely, yeah.
I see. Okay. All right. Let's go back to okay. So this looks like it's not in real time, that it's sort of offline. Is there real-time capability?
Yes, good. This question is very good. You know, I told you this is an offline version of the data, and I talked already about this brownish box up there. In the real-time version, you could take that box and move it on the upper timeline to whatever point in time you would like to see. And the tool is fetching the data from the grid infrastructure management repository and is providing the data in the screen.
I see. So if I make a live connection, I get the full ability to move that cursor up and down my timeline because the data is persisted. But here I'm just looking at a file that's offline, and therefore I'm only seeing the time that's contained in that file.
Yeah, Mark, one of our major design goals for everything in the Cluster Health Advisor was to have a footprint which is really minimal. This is the reason why we don't pull more than 1 hour at one time out of the database for the offline file. Online, we show 1 hour, not more, and the user can move the box to any point in time as long as it's part of the repository. And by default, our repository time, the retention time is 72 hours.
I see. So how do I get this MDB file to analyze?
Excellent question. There is a command line to do that. This is, oh yeah, you show it here. CHA export repository -format MDB -start, then a timestamp -end and the second timestamp.
Okay, so this will give me a big file for the entire timestamp, or
if you specify more than 1 hour, we will cut it into pieces of 1 hour. Let's say you
I
start
see.
with 3 p.m. and you end with 6 p.m. You will get 3 files.
Okay, so we have a question on the chat that says, could you provide some insight into what direction will be with CHA and management database on Exadata environments? Oracle seems to be sending mixed messages on the management DB, at least on Exadata. Okay, so I'm going to hold that question a little bit later, just because it really isn't specific to CHA. CHA is supported on Exadata, and in 19 it has 2 modes of operation. We're going to cover that a little bit later, so I want to set it up properly to make that understanding. So yes, CHA is supported on Exadata and can be used quite effectively, but we're continuing to develop it and even make it more Exadata aware with regards to the storage of the Exadata cells. So we've got this MDB file. Can we walk through a particular usage scenario with CHA?
Yeah, for example, go to the database instance ProdDB1 on the left side. On the
assuming I can get my mouse back here, let's just see what happened here. No, I've lost my cursor. All right. Let's see. Okay, there we go. Okay, there we go. Okay, so go to prod. So that we go to the databases.
Yeah, then we see there are some red bars on the lower timeline. Could you select the ProdDB1, for example?
Okay. All right.
So now we see there are something with a little bit higher bar on the timestamp 1030. Maybe you click on that.
Okay.
So now you see also down there is an finding from CHA. You could click on that.
Okay.
So now we have the root cause. Service time degradation. So we see there's some problems with the ASMIO. You see there's a service time higher than expected, and we see a corrective action to that. And
now these would be the events that I would normally get out of CHA through EM or GFA. This information is what I would normally get.
Yes. Could you press A? Yeah. So now we see you moved also one tick to the right. We're now at the timestamp 10:29:55. If you go one to the right, then we have this higher part. Then we see there's a log file parallel write. We see the time which we got is 28 milliseconds, and the expected time, the predicted time, is 17 milliseconds. So in this model, we are slower than as expected, and therefore we raised this alert.
I see.
We also see when you look at the bar, there's now an additional color, purple color. So it seems to be this event occurs not only once but twice.
I see. Okay, so these two colors, it's hard to see under this cursor because it's short time. So you say these two are correlated then?
Yeah, sorry, I know. I know the colors, therefore easy. So could you switch to the second instance? I would like to see what's going on at the second instance at the same time.
Yeah.
Oh, see, there we have all the time we have some problems with a log file parallel write. So the I/O is not as good as we are expecting it.
So it's also slow relative to
and
what
also
we
you
expect.
see the correlation between the two instances on the two different nodes.
Yeah.
So we could also have a look at the HCMDB one.
Okay.
See, at the same time, we have also here a problem, which makes sense because the database instances are running on the same nodes and using the same I/O subsystem.
Right.
So there are scenarios which we see. One instance is using a hell lot of resources, and the second instance get not enough resources because of that.
I see. Okay.
So, Mark, could you press Shift A on the right? Yeah. So most of you know all the signals from the database. You know the hash data. What we're doing is we're getting the data from a different source, and we are using them as input to our algorithm. And in that case here, we have a lot of different signals, and the difference to all other tools is we see here immediately in the real-time mode live how the different signals, wait events, probes behave.
So we're seeing here disservice time.
Yes, and this is the other thing we have here also information from the host and also from the database correlated in the database model.
Okay. All right. Anything else you want to highlight at this time?
Not this time.
Okay. All right. So you mentioned the predicted values or expected values for each metric. Can I actually see what CHA thinks is the expected value over a period of time instead of at each individual moment?
Yeah, could you have a look at the system again? Maybe you scroll a little bit up. Yeah.
You mean scroll like this?
So stop. Here, for example, this is a nice example. By the way, could you press E? See, here we have a different way to present that with E. You have also to scroll down. I think we lost the because of different scale. We lost that's still fine.
There we go.
So this is the service time we was talking about. You see, we have measured a service time of 11 milliseconds per I/O, and at that time the expected value was 7.95. So our algorithm is checking how the predicted value is compared to the observed value, and as soon as the residual goes over a certain size, we will raise an alarm.
Mm-hmm.
This alarm would
so it's like what we're seeing here in red.
Yes. Yeah. Mm-hmm.
So so we're expecting. So what represents the expected value?
The first value is the observed. So when you look at the disk service time ASM, you see the 12 milliseconds. This is what we measure. This is what we really get from the system. But taking all the signals which are correlated to each other in account, the calculated value, the predicted value would be 8.04 milliseconds.
Okay, so what is this blue color here used for?
This is to show the residual, so the difference between expected and
okay, so
observed value.
So this is the expected. So the top of this is the expected value.
Yeah, the top of the blue is expected, and then we see the measured one in red.
Okay, so we're expecting this. So this gives me very quickly how we're not meeting that objective, but when we're exceeding the blue line. I see.
Yeah. Could you please press the right button?
When you say the right button, you mean the right arrow?
Yeah, the right mouse button. So to get the context menu.
Oh, you mean right click?
Okay. Oh, right click. Sorry.
Okay.
Yeah, I'm still thinking. I'm so long time with the Mac, but I'm still thinking mouse. Sorry.
I see. Okay.
So there's a way to display the residuals as well. You could enable this. Click on that. So then you see the residuals, so the distance.
I see.
There's another way to show the data.
Okay,
sometimes helpful.
I see. Okay. And when you say residual, what do you mean by residual?
This is the distance between the observed and the predicted value.
Okay, I see. Okay, so it's just an arithmetic calculation.
Absolutely, yeah. So when you, I think there's a question mark.
Yeah. The question is the predicted time based upon historic data of the system itself, or are these hard ranges on top of this?
What we do is we have a formula. We have we're using an clustering algorithm. So for each of the values, we have a formula to calculate. And when we have all the data, what we do is we calculate, or the system is calculating the value based on the observed values, and then we're calculating that in real time, and we're compare this to the observed value, and this is the residual for that point in time.
Okay, so we're shipping. What you're saying is we're shipping with a set of predicted values. Is that what you're saying?
No, not really the predicted value. What we do is we ship kind of pre-calculated model.
Okay, so his second follow-up question is, as if the system gradually degrades over time, either by resources or perhaps workloads, and can we accommodate that?
Yeah, you know, Mark, we're delivering models which are based on our gold model. However, not every system is the same. Not every workload is the same. Simple case: during the day, we run a workload with thousands of users in real time working with the system. And during night, we have batch jobs who do something to massage the data at the customer side. So if we run the same model during day and during night, this will bring up a lot of errors, which are not really errors, but are, how you say, kind of false
positive.
False positive, exactly. Sorry, I was looking for that word. And therefore, we have a way to calibrate the models, to calibrate them on certain workloads, or calibrate them on a system which the customer is knowing, oh, this is a case where the system is working well. However, maybe the data we are delivered in our precompiled models are not fit for that model, so we can change that by calibrating the model to their workload.
So then do I have the ability to switch these workloads on a schedule or cron job, switch these models to correspond with my workloads?
Yeah, the customer is capable. Sorry, the customer is capable in naming the models and also switching the models by using, for example, a cron job.
Okay, all right, sounds good. Okay, let's go back to the questions here. What are some of the other scenarios that the GUI is useful for?
In combination for hosts and for databases, we have about 54 different cases modeled. There are cases where memory shortage are. There are cases where we have CPU problems, I/O. We looked at one example for I/O. We have specific problems modeled for interconnect, for dynamic remastering. So there are plenty of different scenarios where the customer can use it and can get value out of the tool.
Okay, so you were focusing on the different, I guess, types of problems we detect.
Yeah.
What about the different uses that the customers could put this tool to?
You're talking about maybe using it post-mortem to look at a scenario which happened over the weekend, for example, or
as an example.
Yeah, you can run it in real time on the cluster. You can see whatever is going on there, but also you can see it post-mortem when you would like to know, yesterday there was a problem. What happens to my database? What happens to my instances? What's going on the database nodes?
So this MRI, this MDB file could be like an MRI of my system, where I've captured all these signals and all of these issues, and I can send them to somebody to triage and diagnose as to the nature of this problem, or this eviction, or this availability issue or performance issue.
Yeah, Mark, since we have the GI management repository, the customer could pick whatever time he would like to have as a retention time. As I mentioned earlier, 72 hours is what we have as default. And he could use that as a repository to see, for example, seasonal changes. He can use it for kind of workload distinction. So he sees the different signals for different workloads. However, what we do is, and what we do for the customer is, we put the generation of MDB files as a part of a TFA. So TFA is collecting MDB files and depends on if the customer is sending them to our support guys. The support guys will use them. The customer
So TFA means trace file analyzer, just for.
I hate these acronyms, and now I'm using them by myself. Sorry.
No problem.
Yeah, trace file analyzer, which is a part of our AHF.
Autonomous Health Framework, yes.
See? Yes.
Okay.
I have a customer in Germany which is using it, and the first thing he did, he changed the default retention time and put the GIMR on a 1 terabyte disk group to make sure he could look at the data, which,
I see.
a year from now, for example. Yeah.
Sure. So you can get quite a retention time that way.
Yes.
Okay. So how can I tell which problems were happening most, frequently? Is we saw that timeline up there.
Yeah.
So is there a correlate? You were mentioning this color.
Yeah.
Is that an indicator of the frequency or the type of problem?
Yeah, and for this instance, this ASM IO service time issue is an issue which is recurring. So, for example, you see, now I have to go closer, sorry. You see all of the bars are correlated. I think the only one, which is the third one, is not correlated. Maybe you can go to
I have
that
to get my mouse back here. Okay, all right. So if
to the left.
Oh, to the left. Okay.
Yeah, and also what you see is you have to click on the root cause. Otherwise, you won't get this color.
I see. Exactly. Okay.
So this before 1010, the one before 1010.
Okay.
You may click there, is faster.
The one before 1010 here?
Yes.
Yeah. Okay, there.
Go to the left, still to the left. More.
Get rid of all these here.
This is a small bar. I told you I had to go close to see it.
Oh, okay. So you mean all the way over to here?
Yes.
Okay.
Yeah.
All right. Okay.
See, this is a different problem, and now you don't see the correlation. So this problem, the I/O is slow for ASM, but in that case, only in that case, the reader log writes are affected.
Okay, so there's another pink bar way over here. So you're saying these two are correlated, but this red area here is a different problem.
Yes, I/O related, but not affecting the reader log writes.
I see. So the GUI tries to link up occurrences of the problem by color coordinating them.
So Mark, you didn't ask me about the gray bar.
Well, okay. What does the gray bar mean?
I told you one of our design goals is, or was, and still is, to be as less invasive as possible. So don't take too much of resources. So our daemons are running not in real time. We don't do machine learning on the fly. We do it in the lab. And here, this is something happened on the system which took all the CPU, and we couldn't report that. One explanation. The other,
sorry, go on.
Go ahead.
No, I was saying this is the times you were referring to right here.
Yeah,
at 10,
exactly.
20 or so. Yeah.
So this is one of the possible reasons. The other one, which I think in that case happens, was that the database got shut down and restarted.
Okay. Well, in this case, we don't actually have that data in the file because that predates the hour, right?
Yes.
Okay. Yeah. Okay. All right. So where can I get this tool, the CHA GUI?
I think if I'm right, there's a MOS node for that. Oh yeah, here it is. So a customer can download the tool via MOS.
Mm-hmm. So here's the reference to the MOS node that they can. So as long as they have access to the MOS system, they can make use of this tool.
Mark, there was a plan to have it on OTN as well. Is this still ongoing?
Their OTN is currently being updated to a new look and feel, and so we can't put anything new up there yet. But so it right now is only available via MOS,
which is sufficient for most of the customers.
Yeah. Okay, so what's involved in installing the GUI here?
This is quite a simple installation. If you go for the offline mode, the customer could download the zip file, which includes the documentation as well, unzip it, and oh yeah, you show it here, the user manual, and also the installation is the description for the installation is here. Yeah, the only thing he needs is Java. I think currently we're supporting Java 8, and for the local version, so if he has created the MDB file and downloaded from the cluster to his local laptop or PC, he can start the GUI and can start browsing through the MDB file directly.
Okay, so he just has to run this CHAG command to get the, presumably this one here with the MDB file.
Yes, with -f, yeah.
Yeah. Okay.
So, and in the real-time or live mode, the customer has to install it or to unpack it. It's not an installation per se, it's an unpack it on one of the cluster machines. The recommendation is not in the Oracle Home, in a separate place, but he needs to set Oracle Home. He needs to set the LD library path.
And obviously he needs X running on that machine because this is uses Java Swing and a GUI interface, right?
Yes. Yeah.
Which not all customers have on their database machines.
True.
Okay. So what database versions does CHA and the GUI support?
I think 12.2 is the first version we are supporting with CHA GUI. By default,
the versions
ORAchk
that
enable.
all the versions that actually CHA supports.
Yeah.
Wait, I lost audio.
Mark?
Sorry about that. So it supports all versions that CHA supports.
Yes.
From 12.2.
Yes.
Yeah. Okay. So, sorry, my audio dropped for a moment there.
No worries.
Okay. Okay. Does this tool require the management repository to be deployed?
Yes.
This gets back to this other question we had.
Yeah, we have to access the data, and as I mentioned earlier, the grid infrastructure management repository is mandatory. We need a place where the data ORAchk collected gets stored in, and that data will reading out, and also for the offline version, the CHA CTL utility, the command line utility, is connecting to that database and is retrieving the signals, the data out of that repository. By the way, the MDB
yeah,
file is a text file, so customer can look through it. There is nothing, how you say, specific, customer specific in. So this was one of our decisions not to compress it or to encrypt it.
Encrypted. Okay, so somebody asked, but the GMR is not there in 19C now, I think. That is not entirely correct. It is optional, and there is a local mode that CHA can run in to actually generate events if you don't have the management repository installed. So you'll get the event generation. The problem is you will not get the historical ability to go back in time and look at events. You will just get the events as they are generated. And so as a result, the ability to use a tool like this will be is not there if the management repository isn't. We should also mention that there is the capability to set up a centralized management repository and have which we call the domain services cluster if you want to centralize that feature, or you can add a management repository after the fact if you didn't select it to begin with and want to add it later. You can do that, and there are scripts on Moss, either Moss notes, to go through that if you haven't installed it but want it later.
And
Okay.
One
Yeah.
remark, Mark, when you have installed the GIMR later, immediately after the GIMR is up and running, OChat will recognize that and will start writing into the repository instead of into the file system.
Correct. Yes. Good clarification there.
And maybe the other thing is before 19, the only thing which we are monitored automatically was the host. In order to monitor the database, you have to run a SHA-CTL command.
Yes. So yeah, just for people clarification here, even though we announce this as a rack session, CHA is only licensed to be and only works against rack databases. And once a rack database comes up in the cluster, we start monitoring the nodes. And then as Klaus mentioned, you can therefore manually decide which databases you want to monitor through the CHA-CTL command.
So Mark, this means there's no additional license required to use.
Right.
Only RUC has to be there.
Yes. So the fact that we're getting signals that would normally be in the diagnostic pack or, ADDM, and using those signals, the customer doesn't have to have those options because we're using them versus the customer using it for his own purposes. Okay. Oops. So there is another CHA tool that we actually had a session about a few months ago called the CHA Finding Explorer. How do these two tools, both available on Moss, compare?
I would use the CHA Finding Explorer as the first step to figure out in, let's say, the last 24 hours, which are the hours which are highly interested to look at. And then I would generate the MDB files for that time, and use CHA to do and kind of deep dive, look at the signals, look at the decisions, and so on.
Yeah, so CHA Finding Explorer uses the CHA-CTL query diagnosis command to capture all the events and is able to display them as you see here, and even gives you a tally of the most frequent events and across time, and you can see the selectable timeline, as you were mentioning. We can narrow down to particular time periods where a lot of problems might have been happening, such as this time here. Or you can filter out certain problems if you're only looking at specific ones. So they look like they're complementary tools that could be used together.
So not complementary. So really,
yeah, they're complementary.
Yeah, complementary.
Yeah, yeah. Okay. What we're going to do is now open up for those were the pre-planned questions. Are there any other questions that our audience might have that could enter into the chat? All right. Well, it doesn't look like we've got any additional questions. I want to thank you, Klaus, for spending time with us. Okay, here's one. Okay, is it necessary to run the CHA at the server side? I think they're referring to the CHA GUI. If you want to clarify this, can we run this at the client, at a client machine? Okay, so yes, okay, he clarified. So as we mentioned, if it's running right now against in live mode, you need to run it on the server side. Is that correct?
Yes, that's correct.
But if you want to run it in offline mode with the MDV file, you can run it on a client machine.
You can run it on any machine where Java is supported.
Right, right. Yeah, you don't need an Oracle home there. You just need Java. Yeah. So currently the only way to run it in live mode is actually on one of the cluster nodes. It doesn't have to be a specific node, correct?
Yes.
Yeah. Okay. Okay, so that's the answer. Any other questions? All right. Well, I want to thank everybody for attending, and our next session will be on the fourth Tuesday of October. So look for the announcement, and please subscribe to the Ask Tom Office Hours channel to get the latest uploads. And I said this session is going to be processed. It takes about a week, but you can get a time indexed version of it on the Ask Tom channel on YouTube once we push it out there. So thank you, Klaus. Thank you, everyone.
Thank you, Mark. Thank you, everyone.
See you guys next month.